Greetings, folks. Today I'd like to talk about spectrophotometry and our spectrophotometry lab. Spectrophotometry is a technique that uses light to determine the concentration of a sample. In order to do this, a light source is used to shine white light of all colors, through a prism or grating. That prism then splits the light into different colors, and then those different colors of light can be selected using the slit on the spectrophotometer. In that way, we can assure that we're only sending one color of light through our sample to read out on our detector. Now, our spectrophotometers can measure two different quantities. The first is the transmittance of the sample. The transmittance is just a ratio of how much light gets through the sample. The more light that gets through, the higher the transmittance. A completely blank sample should let 100% of the light get through, and so the transmittance would be 100% for a blank sample, similar to what we used in our lab. Now, the opposite of a transmittance is an absorbance. And our spectrophotometers can measure that as well. And absorbance is what we cared about more in our lab. Absorbance is the opposite of transmittance. It's how much light is absorbed. The more light that is absorbed, the lower the transmittance, and the higher the absorbance. Now, the first step of our lab was to determine what wavelength our solution of copper nitrate absorbed the most in. So our copper nitrate looked a lot like this guy. It was blue. But interestingly enough, blue solutions do not absorb blue light. And so the first thing we did was we created a graph of absorbance versus wavelength for just one of our solutions, the 0.5 molar. And so we created a curve, and that curve should have looked a lot like this. So this is a classic absorbance curve for a sample, where you have different wavelengths down here. Let's say it ranged from somewhere like 400 nanometers over here to 700 nanometers. This peak right here shows you the wavelength of max absorbance for your sample. It shows you what color of light is being mostly absorbed by your sample here. For example, in our lab, that fell right around here in the orange part of the spectrum. The electromagnetic spectrum heads from over here in 400 nanometers, violet light and indigo light down over here, then to blue, then green, then yellow, and then orange, and then finally red, all the way out to 700 nanometers, just like Roy G. Biv, but in reverse. So we first wanted to figure out, okay, what does this graph look like for my sample so that I can choose to measure all my other samples just at this wavelength of max absorbance. That's important. This gives us a lot of range to play with our sample. If we were taking measurements way down here, our absorbance wouldn't change very much when we put in another sample. So this gives us the most range and most difference when we're using our spectrophotometer. Finally, the last thing that we had to create was what is called a calibration curve. And to make a calibration curve, what you need to do is you want to measure at one wavelength, so choose your maximum wavelength, you want to measure the absorbances of samples of different concentration. And so we would get a graph of absorbance versus concentration, which is normally measured in molar. And what you should have seen was a lot of different points that ended up making a pretty linear relationship. Now that linear relationship, we call that Beer's law. And Beer's law states that the absorbance A, or I'll just call it ABS, is equal to ABC, where A is the absorptivity or molar absorptivity of your sample. That for us is going to be equal to the slope of this trend line. That's what's going to give us our molar absorptivity. B is the length of our sample, which for us was just 1 centimeter. And so we don't need to worry about B in our equations here. And then finally, of course, C is our concentration. So the calibration curve is what actually allows us to determine the concentration of our unknown solutions. When we make this calibration curve, we get a value for this slope. We now know what A is. So we have a relationship between absorbance and concentration for our sample here. And so then we can measure unknown solutions and then compare it to that. So your goal on this lab report is to determine the concentrations of your unknown solution. You want to make sure you talk about the differences between transmittance and absorbance, why your solution absorbed most here, and the orange wavelength, and talk about your absorbance versus wavelength curve. And then finally, make sure you mention your calibration curve and the slope of your line being related to Beer's law. Thank you, folks. Have a great day.